Let's discover why solids, liquids, and gases have different densities. Have you ever wondered why a rock sinks in water, water flows freely, and air is almost impossible to see? The answer lies in one important property called density. Why do the densities of different states of matter vary? Let's discover how intermolecular forces determine the density of solids, liquids, and gases. Density tells us how tightly packed the particles are in a material. The closer the particles are, the more mass is packed into a given space, and the higher the density. It depends on the mass of the substance and how much space it occupies, that is, volume. Different substances have varying densities. For example, aluminium is about 2.7 times denser than water. Water is about 11,000 times denser than hydrogen gas. Hydrogen is one of the lightest elements, which is why it is used in weather balloons and rises rapidly in air. Density tells us how much mass is packed into a given volume. In simple words, the more closely packed the particles are, the higher the density. However, it is important to remember that not all solids are denser than liquids. For example, wood, which is a solid, is less dense than water. Knowing a substance's density helps determine whether it will float or sink in another substance. A lemon floating in water is a great real-life example of density. An object less dense than the surrounding liquid will float. Conversely, an object denser than the liquid will sink. Since the densities are primarily affected by how particles are closely spaced, the density of substances changes when they also change state. As a substance heats up, its particles gain energy and move more, causing them to take up more space, decreasing its density. Conversely, cooling a substance slows down its particles, causing them to occupy less space, increasing its density. Solid gold, for example, is denser than its molten counterpart. The mass remains the same, the volume increases, so the density decreases. Now let's take a closer look at the density of water in its different states. What do you notice? Its solid form, that is ice, is less dense than its liquid form. Water is unique compared to other substances because it is less dense as a solid than as a liquid. That's why ice floats on water. This anomaly is due to the orientation of the hydrogen bonds as water freezes. Slightly positive hydrogen atoms are attracted to slightly negative oxygen atoms, forming a crystalline structure. In ice, each water molecule forms hydrogen bonds with 4 other water molecules. Consequently, water molecules in ice are pushed further apart compared to liquid water, resulting in a hexagonal structure in ice. The lower density of ice than liquid water explains why ice cubes and icebergs float. Now let's take a quick recap. Density tells us how tightly packed the particles are in a material. Generally, solids have the highest densities, while gases have the lowest. Density also changes when the state of a substance changes. As substances are heated, molecules move more and occupy more space, decreasing their overall density. How does the anomalous expansion of water contribute to preserving aquatic life during extremely cold weather? Beneath the ice, the deeper water remains close to 4 degrees Celsius, which is warm enough for fish and other aquatic organisms to survive. As we've seen, the anomalous expansion of water is one of nature's most remarkable phenomena. Unlike most substances, water becomes less dense when it freezes, causing ice to float on the surface instead of sinking. Understanding density not only helps us grasp the behavior of solids, liquids, and gases, but also reveals how the arrangement of tiny particles influences the physical world we see every day. If you enjoyed this lesson, don't forget to like, share, and subscribe for more science concepts. Thanks for watching, and keep exploring the science behind everyday life.